Ever wondered how complex data can be broken down into its most essential parts? That's where Singular Value Decomposition, SVD, comes in. This powerful technique is used for dimensionality reduction, noise reduction, and even recommendation systems. Welcome to day 23 of the 30 Days of Machine Learning series. If you're just joining, don't worry. You can click right here to access the full playlist and catch up on every step of the journey so far. And hey, make sure to hit that subscribe button so the next video in this series drives straight into your feed. Today, we'll explore SVD, how it works, why it's so useful, and how to implement it in Python. By the end of this video, you'll see just how powerful SVD can be. Let's get started. First, let's bring in the essential libraries. Pandas for handling data, NumPy for numerical operations, Matplotlib and Seaborn for stunning visualizations. These will make our work seamless. Let's load our dataset and take a quick peek at the first few rows. Next, we'll check for missing values, because unnoticed gaps can mess up our analysis. Time to clean our data. We're dropping columns with too many missing values and filling the rest with their mean, keeping things balanced and usable. Let's inspect our dataset, checking column names, dimensions, and ensuring no missing values remain. A quick scan now saves us from surprises later. Now let's encode categorical data into numerical values. I'm using Label Encoder to convert text columns into numbers. This ensures our machine learning model can work with them effectively. Each column gets its own encoder, so we can decode them back later if needed. Now let's standardize our data with Standard Scalar. This ensures all features have a mean of 0 and a standard deviation of 1, making our model perform optimally. Scaling is key for better results. Let's visualize the correlation between features using a heat map. This will help us understand the relationships and detect patterns. Next, we apply truncated singular value decomposition to reduce the dimensionality of our data. By keeping the most important components, we simplify the dataset while retaining its key features. This makes our model more efficient and effective, especially when dealing with large datasets with many features. Now let's look at the explained variance ratio. It tells us how much each component contributes to the data's variability. Now let's compare the original data with the transformed data using SVD. On the left, we have the original scaled features plotted against each other. On the right, we visualize the data in its reduced form, showing the first two SVD components. You'll notice how the transformed data might look more compact and easier to work with, even though it's capturing the same information. This dimensionality reduction simplifies our problem and helps improve model performance. The comparison shows how SVD effectively retains the most important data patterns while discarding noise. Let's see how it all unfolds. Here, we're preparing our target variable, y. If it's continuous, float, or int, we'll convert it into categorical bins using QCUT, dividing it into 4 equal groups. This way, we can treat it as a classification problem instead of regression. Now we're splitting our data into training and testing sets. With 80% of the data for training and 20% for testing, we can evaluate how well our model performs on unseen data. Next, we're training a gradient boosting classifier on our training data. It's a powerful ensemble method that combines multiple models to improve accuracy. Let's see how it learns from the data. We've made predictions on the test set and now evaluate our model's performance. The accuracy score tells us how well it did, while the classification report gives detailed insights on precision, recall, and F1 score for each class. We've successfully reduced our data's dimensions with SVD and built a model to predict outcomes efficiently. But that's not all. Next, we'll dive into one-hot encoding, a technique that turns categorical data into a format your model can easily understand. Click on the screen to continue and unlock the power of one-hot encoding in our next video.